Welcome to the deep dive. So, you've given us a chapter from a text about AI and law, and we are so ready to break it down with you, listener.
Yeah, get ready to demystify generative AI.
We're going beyond the hype
Yeah,
and getting into how it really works.
the nuts and
We're
bolts.
talking neural networks and large language models, the brains behind things like ChatGPT, and even that revolutionary transformer architecture. It's going to be a lot, but it's going to be great.
It is exciting stuff, especially, when you start to see how these technologies can be applied in a field like law.
And that's what we're going to explore today.
hmm
The chapter kicks off kind of just defining AI. It seems like every day there's a new article about AI, and sometimes it can feel like magic.
It can, but underneath it all, AI really comes down to pattern recognition. Yeah. It's about computers performing tasks that typically require human intelligence. So like recognizing a face in a crowd. Or in the legal world, maybe analyzing a contract for specific clauses.
And the chapter breaks down machine learning into three main types: supervised, unsupervised, and reinforcement learning. Can you give us a crash course on those, especially as they relate to the legal world?
Absolutely. So supervised learning is like giving the AI a set of labeled data. So let's say you're training a system to identify relevant documents for a case. You feed it examples of documents that are relevant and others that aren't. And the AI learns from these examples to then predict which new documents might be relevant to your case.
So it's learning by example, kind of like training a dog with treats.
Exactly.
Okay.
Now, unsupervised learning is more about finding hidden patterns in data. So imagine giving the AI a pile of legal documents and saying, find some connections here. And it might be able to group similar cases together or identify emerging trends in legal arguments.
Interesting. So supervised learning is about teaching the AI specific tasks, while unsupervised is more about letting it explore and find its own insights.
Yeah, that's a great way to put it. And then there's reinforcement learning. And this is where the AI learns through trial and error and getting feedback for its actions. So think of a legal AI system that helps lawyers negotiate settlements. It might try different strategies and learn which ones lead to the best outcomes for its client.
Okay, I'm starting to see how these different types of learning could be applied in a legal setting. But the chapter also talks about deep learning. Is that just a fancy buzzword, or is there something more to it?
Deep learning is where things get really interesting. It involves these things called neural networks, which are inspired by the way our own brains work.
Okay.
They consist of layers of interconnected neurons that process information and pass it on to the next layer.
So are we talking about building AI that thinks like a human?
Not exactly.
Okay.
It's more about using a simplified model of the brain to enable AI to learn more complex patterns.
hmm
So the simplest unit in a neural network is called a perceptron, and you can think of it like a tiny decision maker.
Okay, break that down for me. How does a perceptron make a decision?
Imagine you have a bunch of inputs. Like let's say the words in a legal document.
Okay.
The perceptron takes those inputs, applies some mathematical calculations to them using something called weights, and then it spits out an output, a decision, if you will.
So the weights determine how much importance the perceptron gives to each input.
Exactly.
Okay.
And by adjusting those weights during training, the neural network learns to make better and better decisions.
Got it. Now, the chapter keeps mentioning large language models, or LLMs. What makes them so special?
LLMs, like ChatGPT, are really the powerhouses behind a lot of the generative AI we see today. They are neural networks specifically designed to process and generate language. And they are massive, with billions, even trillions of parameters.
Trillions. That's mind-boggling. What does having so many parameters actually do?
Each parameter is like a tiny dial that gets adjusted during training to improve the model's accuracy. So think of it like this. The more parameters an LLM has, the more nuances of language it can capture.
So it's like having a super sensitive instrument instead of like a basic tuning fork.
Yeah.
More dials, more precision.
That's a great analogy. That's why these models can write such realistic text and even hold seemingly intelligent conversations. They've learned so many patterns from the vast amounts of data they've been trained on.
But with all that data, isn't there a risk that the AI could learn the wrong patterns or develop biases based on the data that's been fed?
Data quality is absolutely crucial, and it's something we're going to discuss in more detail, later on. But for now, let's focus on another key aspect of LLMs, the transformer architecture. And this is a real game changer in the world of AI, especially for language processing.
Okay, I'm intrigued. What makes transformers so revolutionary?
So before transformers, AI models process language in a very linear way, like one word at a time.
Uh-huh.
But transformers changed all that by allowing the model to look at all the words in a sentence simultaneously and figure out which ones are most important to each other.
So it's like the AI is reading the whole sentence at once, not just word by word.
Exactly. It's like being able to see the whole forest instead of just individual trees.
Yeah.
And this is achieved through something called attention, which is basically the model's ability to weigh how relevant each word is to the others in the sentence.
That makes sense. I mean, in a sentence like, the lawyer, who was feeling tired, presented her argument. It's important to know that tired is describing the lawyer, not the argument.
Precisely. And transformers excel at understanding those relationships between words, even in complex sentences with multiple clauses and pronouns.
Okay.
For example, the chapter breaks down the sentence, "When Jane realized she had forgotten her bag, she rushed back to the store where Mark had hidden it behind the counter so no one else would take it."
That's a pretty complex sentence.
Yep. It is. And a transformer can keep track of who's who and what's what. It understands that she refers to Jane, her refers to Jane's bag, and it refers to the same bag that Mark hid. This ability to track those references is what allows it to understand the meaning of the sentence so accurately.
That's impressive. So transformers are kind of like the secret sauce behind ChatGPT's ability to understand and generate such human-like text.
They play a huge part, for sure. But it's not just about understanding language, it's also about generating it. And that's where the concept of interpolation versus extrapolation comes in.
Okay, break those down for me.
So think of interpolation like filling in the blanks.
Yeah.
If an LLM has seen thousands of contracts, it can probably generate a new one that follows the same basic patterns.
So it's basically recombining elements it already knows.
Exactly. But extrapolation is about coming up with something truly new, something that goes beyond the patterns it's seen in the data.
Ah, so it's like trying to write a completely new type of legal document that's never existed before.
Right. And while LLMs excel at interpolation, extrapolation is a much bigger challenge for them.
That makes sense. And I imagine that distinction is especially important in legal scenarios where you might encounter situations that are truly unique and haven't been addressed in existing case law.
Exactly. It's crucial to understand the limitations of these models. Even as we marvel at their capabilities, they're incredibly powerful tools. But they're not a replacement for human judgment and expertise, especially in a field as nuanced as law.
So we've talked about how LLMs learn from these massive amounts of data. But what about the actual process of learning? How do they know what to focus on and how to adjust their parameters to get better at what they do?
Yeah, that's where the concept of gradient descent comes in. It's the algorithm that guides the AI's learning process. And, it's actually a bit like finding your way down a mountain in the dark.
Okay, I'm picturing myself stumbling around with a flashlight. How does that relate to AI?
Well, imagine you can only see a few steps ahead of you. You take a step, and you feel if the ground is sloping downward or upward. If it's downward, you keep going that way. If it's upward, you try a different direction.
Okay.
So gradient descent works in a similar way.
So the AI is constantly testing out different parameter settings, seeing which ones lead to more accurate predictions, and then adjusting its course accordingly.
Exactly. It's like a process of trial and error, but it's guided by this algorithm that helps the AI systematically move towards its goal, which is to minimize errors and improve its accuracy.
Fascinating. Okay, another concept the chapter dives into is that of vectors and embeddings. I'll admit, those words make me think of high school math class, and not necessarily in a good way.
I understand. But it's actually not as complicated as it sounds. Remember how we talked about AI's core strength being pattern recognition?
Mm-hmm.
Well, to recognize patterns in language, the AI needs a way to represent words in a way that a computer can understand.
So we're talking about turning words into numbers.
Precisely. That's where vectors and embeddings come in. So a vector is basically a list of numbers that represents a word or a concept.
Okay.
Think of it like describing your friend, right? You might say they're tall, have brown hair, are from a certain city, and love a particular sports team.
Yeah.
Each of those characteristics is like a dimension in a vector.
So the more dimensions you add, the more detailed and unique the description of your friend becomes.
Exactly. And that's what word embeddings do. They capture the meaning of a word by representing it as a vector with many dimensions based on its relationship to other words.
Okay. So how does that help the AI understand language?
Well, words with similar meanings will have similar vectors. So, for example, lawyer and attorney would have vectors that are very close together in this multidimensional space, while dog and car would be much farther apart.
So it's like creating a map of language where words that are close together in meaning are also close together spatially.
That's a great way to visualize it. And this map allows the AI to see relationships between words, even if it hasn't been explicitly taught those relationships.
That's pretty amazing. It's like the AI is developing its own understanding of language based on how words are used and how they relate to each other.
Exactly. It's a form of learning that goes beyond memorization and starts to resemble something closer to, human understanding, at least in a mathematical sense.
Now let's circle back to reinforcement learning, particularly the kind that involves human feedback. This is the technique that makes ChatGPT feel so conversational, right?
It is. It's called reinforcement learning with human feedback, or RLHF.
Mm-hmm.
It's a crucial part of what makes these large language models so good at interacting with humans in a way that feels natural and engaging.
So how does RLHF actually work? Are humans just giving the AI a thumbs up or thumbs down on its responses?
It's more nuanced than that. Human trainers actually evaluate the AI's responses based on a variety of criteria, like accuracy, helpfulness, clarity, and even how well the response aligns with human values.
So we're basically teaching the AI how to communicate effectively and appropriately in a human context.
Exactly. The AI learns from this feedback
Right.
and gets better at generating responses that are not only accurate, but also relevant, informative, and engaging for humans.
That makes sense. Now, the chapter also mentions something called the scaling hypothesis. What's that all about?
The scaling hypothesis is a pretty fascinating idea. It suggests that as we scale up AI, using larger models, more data, and more computing power, the smarter it will become.
So it's like saying if we just keep feeding the AI more and more resources, it will eventually reach like human level intelligence or even surpass it.
That's the gist of it. Though there's a lot of debate about how far scaling alone can take us. However, there's no doubt that scaling up AI has led to some incredible advancements in recent years.
Just look at ChatGPT. It seems like it's getting smarter and more capable every day.
It's true. The pace of progress is remarkable. But it's important to remember that scaling isn't the only factor. We also need to consider the quality of the data that we're using to train these models.
Right. We touched on that earlier. Bad data can lead to inaccurate or biased results, even if the AI itself is incredibly powerful.
Exactly. And that brings us to a rather thought-provoking question. Are we running out of high-quality data to train these massive AIs?
Wait, running out of data. But isn't the internet practically infinite?
It's vast, for sure.
Yeah.
But there's a limit to the amount of high-quality text data that's readily available and suitable for training LLMs.
So what happens then? Do we hit a wall with AI development?
Researchers are exploring different solutions. And one of the most promising avenues is the use of synthetic data,
Okay.
AI-generated content that can be used to supplement real-world data.
Interesting. So we're talking about using AI to create more data to train AI.
Exactly. It's a bit like a snake eating its own tail. But it has the potential to unlock, significant advancements in AI capabilities.
But wouldn't that create a risk of reinforcing existing biases or even introducing new ones if the AI is generating its own training data based on what it's already learned?
That's a valid concern, and it's something that researchers are actively working to address. The key is to ensure that the synthetic data is diverse, balanced, and representative of the real world.
So it's about using AI to create data that expands the AI's horizons, not just reinforces what it already knows.
Precisely. Synthetic data has a potential to be a really powerful tool, but we need to use it carefully and thoughtfully. And this ties into a broader point that the chapter emphasizes, which is the importance of understanding how AI systems work.
Right. It's not enough to just use the tools. We need to understand their limitations, their potential biases, and the ethical implications of using them in a field like law.
Absolutely. And that's why this chapter encourages us to go beyond the surface level and delve into the technical details of how these systems operate.
Speaking of getting hands-on, the chapter also mentions a tool called the Transformer Explainer. Have you ever used that?
Oh, yeah. It's a great tool. It allows you to input a sentence and actually see what the AI is focusing on as it processes the language and makes predictions. It's like a window into the AI's thought process.
That sounds amazing. I'm definitely going to check that out. It seems like a great way to solidify the concepts we've been discussing about attention and context. Okay, we've covered a lot of ground here. We've explored different types of machine learning, delved into the inner workings of neural networks, and even pondered the future of data and the potential of synthetic data. What else does this chapter have in store for us?
Well, there's one more key aspect of generative AI that we need to discuss, and that's the idea of weights and biases.
Hmm.
These are the internal parameters that determine how the AI processes information and makes decisions. And understanding how they work is crucial for understanding both the power and the limitations of these systems.
We're back and ready for the final part of our deep dive into generative AI.
It's been quite a journey, hasn't it? We've covered a lot of ground from the basics of machine learning to those really powerful large language models that can generate human quality text.
And just before the break, you mentioned weights and biases. These sound like pretty fundamental concepts.
Right.
Can you unpack those for us a bit?
Yeah, remember how we talked about perceptrons?
Yeah.
Those tiny decision makers within a neural network?
Uh-huh.
Well, weights and biases are like the internal settings that determine how a perceptron processes its inputs.
Okay, let's start with weights. What exactly do they weigh?
So think of it like this. Each input to a perceptron, say a word in a sentence, has a certain weight assigned to it.
Okay.
That weight determines how much influence that particular input has on the perceptron's final decision.
So a word with a high weight would have a stronger impact on the output than a word with a low weight.
Exactly.
Yeah.
And these weights are adjusted during training as the AI learns from its mistakes and gets better at making accurate predictions.
Okay, that makes sense. Now, what about biases? How do they fit into the picture?
So a bias is like an additional factor that's added to the perceptron's calculations. It's a constant value that can shift the output up or down, regardless of the inputs.
So it's like a baseline setting that influences the overall decision-making process.
That's a great way to think about it.
Okay.
Biases and weights work together to fine-tune the perceptron's behavior, allowing the neural network to learn those complex patterns and make more accurate predictions.
It's amazing to think that all of this complex processing is happening behind the scenes when we're interacting with something like ChatGPT.
It is. And the key takeaway here is that the AI's output is a direct result of these weights and biases, which are shaped by the data it's been trained on.
Which brings us back to the importance of data quality.
Exactly. If the training data is flawed, the AI's weights and biases will reflect those flaws. And that can lead to, inaccurate, biased, or even harmful outputs.
That makes perfect sense. It's a reminder that AI is a tool. And like any tool, it can be used for good or for bad. It all depends on how it's built, how it's trained, and ultimately how it's used.
I completely agree. And that's why it's so important for people, especially in the legal profession, to have at least, a basic understanding of how these AI systems work. We need to be able to critically evaluate their outputs, recognize their limitations, and use them responsibly.
This deep dive has definitely opened my eyes to the complexities of generative AI. It's clear that this technology has the potential to revolutionize the legal field, but we need to approach it with caution and awareness.
I couldn't agree more. This chapter has given us a really solid foundation for understanding the key concepts and potential implications of generative AI in law.
It's also highlighted the importance of staying informed and engaged as this technology continues to evolve.
Absolutely. The world of AI is changing rapidly, and it's up to us to stay curious, keep learning, and make sure we're using these powerful tools in a way that benefits everyone.
Well said. I think we've covered just about everything from this chapter. Any final thoughts before we wrap up this deep dive?
I would just encourage everyone listening to keep exploring the world of AI
Yeah.
and its impact on the legal profession. This is just the beginning of a very exciting journey, and there's so much more to learn and discover.
I couldn't agree more. And who knows, maybe in a few years we'll be doing another deep dive on some groundbreaking new AI technology that we can't even imagine today.
Yeah, that's the beauty of this field, isn't it? It's constantly pushing the boundaries of what's possible.
Yeah.
So stay curious, stay engaged, and let's see where this journey takes us.
Thanks for joining us on this deep dive into generative AI. Until next time, keep exploring.